Welcome to our journey into environmental chemistry, where we explore how chemical processes impact our planet. Environmental chemistry is the study of chemical phenomena in the environment, focusing on the sources, reactions, transport effects, and fates of chemical species in air, water, and soil. In this video, we'll break down the science behind pollution, greenhouse gases, and the ozone layer. By understanding these concepts, we can better appreciate the delicate balance that sustains life on Earth and the challenges we face in protecting our environment. Let's start by looking at what pollution really means and why it matters. Pollution refers to the introduction of harmful substances or products into the environment. These pollutants can be chemical, physical, or biological agents that disrupt natural processes and harm living organisms. Pollution can affect air, water, and soil, leading to a range of environmental and health problems. Common sources include industrial activities, vehicle emissions, agricultural chemicals, and waste disposal. Understanding the types and sources of pollution is the first step in finding solutions to reduce their impact. Next, we'll examine the major types of pollution and how they differ. There are several main types of pollution: air, water, and soil pollution. Air pollution involves the release of harmful gases and particles into the atmosphere, often from burning fossil fuels. Water pollution occurs when chemicals, waste, or microorganisms contaminate rivers, lakes, or oceans. Soil pollution results from the accumulation of toxic substances in the ground, often due to pesticides or industrial waste. Each type of pollution has unique causes and consequences, but all pose serious risks to ecosystems and human health. Let's focus first on air pollution and its chemical origins. Air pollution is a major environmental issue, especially in urban areas. It's caused by the emission of pollutants like carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter. These substances come from vehicles, factories, power plants, and even natural events like wildfires or volcanic eruptions. Once in the air, these chemicals can react with sunlight and other compounds, forming smog or acid rain. Air pollution not only harms our lungs but also affects climate and weather patterns. Next, we'll look at the chemistry behind these pollutants. Let's dive into the chemistry of common air pollutants. Carbon monoxide is produced by incomplete combustion of fuels and binds to hemoglobin, reducing oxygen transport in our bodies. Sulfur dioxide and nitrogen oxides released from burning coal and oil can react with water vapor to form acids, leading to acid rain. Particulate matter consists of tiny solid or liquid particles that can penetrate deep into the lungs. Understanding these chemical reactions helps us see why controlling emissions is so important. Now, let's explore the concept of greenhouse gases. Greenhouse gases are a group of compounds that trap heat in the Earth's atmosphere, keeping our planet warm enough to support life. The most important greenhouse gases include carbon dioxide, methane, nitrous oxide, and water vapor. While these gases are naturally present, human activities like burning fossil fuels, agriculture, and deforestation have increased their concentrations. This leads to more heat being trapped, causing global temperatures to rise, a phenomenon known as global warming. Let's see how these gases work in the atmosphere. Greenhouse effect is a natural process where greenhouse gases absorb and emit infrared radiation, warming the Earth's surface. Without this effect, our planet would be too cold for life. However, human activities have intensified the greenhouse effect by adding more greenhouse gases to the atmosphere. This extra warming disrupts weather patterns, melts glaciers, and raises sea levels. Understanding the greenhouse effect is key to addressing climate change. Next, we'll look at the main sources of these gases. Greenhouse gases come from both natural and human-made sources. Natural sources include volcanic eruptions, respiration, and decomposition. Human sources are mainly from burning fossil fuels for energy, industrial processes, agriculture, and land use changes like deforestation. For example, cars and power plants emit carbon dioxide, while livestock farming releases methane. By identifying these sources, we can target efforts to reduce emissions and slow global warming. Now let's explore how greenhouse gases affect the climate. Buildup of greenhouse gases in the atmosphere leads to climate change. This means more frequent heat waves, stronger storms, droughts, and rising sea levels. These changes threaten ecosystems, agriculture, and human health. Scientists use climate models to predict future impacts and guide policy decisions. Reducing greenhouse gas emissions is crucial for limiting global warming and protecting our planet. Next, we'll shift our focus to another critical environmental issue: the ozone layer. Ozone layer is a region of the Earth's stratosphere that contains a high concentration of ozone O3 molecules. It acts as a protective shield, absorbing most of the sun's harmful ultraviolet UV radiation. Without the ozone layer, life on Earth would be exposed to dangerous levels of UV rays, increasing the risk of skin cancer and harming plants and animals. Let's see how ozone is formed and why it's so important for life. Ozone in the stratosphere forms when ultraviolet light from the sun splits oxygen molecules, O2, into individual atoms. These atoms then combine with other oxygen molecules to form ozone O3. This process creates a dynamic balance, with ozone constantly being created and destroyed. The ozone layer's ability to absorb UV radiation depends on this balance. Disruptions to this process can weaken the ozone shield, making it less effective at protecting life on Earth. Next, we'll discuss what threatens the ozone layer. Ozone depletion refers to the thinning of the ozone layer, mainly caused by human-made chemicals called chlorofluorocarbons (CFCs). These compounds were once widely used in refrigeration, air conditioning, and aerosol sprays. When CFCs reach the stratosphere, they are broken down by UV light, releasing chlorine atoms that destroy ozone molecules. This leads to the formation of the ozone hole over Antarctica and increases UV radiation reaching the Earth's surface. Let's look at the chemistry behind this destructive process. Destruction of ozone involves a series of chemical reactions. When CFCs are broken down by UV light, they release chlorine atoms. These chlorine atoms react with ozone molecules, converting them back into oxygen and depleting the ozone layer. One chlorine atom can destroy thousands of ozone molecules before being removed from the atmosphere. This chain reaction is why even small amounts of CFCs can have a big impact. Thankfully, international agreements have helped reduce CFC emissions, but recovery is slow. Losing ozone protection means more ultraviolet radiation reaches the Earth's surface. This can lead to higher rates of skin cancer, cataracts, and immune system suppression in humans. It also harms plants, marine life, and animals, disrupting entire ecosystems. Increased UV can reduce crop yields and damage phytoplankton, which are vital for ocean food chains. Protecting the ozone layer is essential for the health of all living things. Next, we'll discuss how pollution and greenhouse gases are connected to ozone chemistry. Air pollutants, such as nitrogen oxides and volatile organic compounds, can also influence ozone chemistry. In the lower atmosphere, these chemicals react in sunlight to form ground-level ozone, a major component of smog. While ozone is beneficial in the stratosphere, it's harmful at ground level, causing respiratory problems and damaging crops. This dual role of ozone highlights the complexity of environmental chemistry and the need for careful management of pollutants. Smog is a type of air pollution that forms when sunlight reacts with pollutants like nitrogen oxides and volatile organic compounds. This reaction produces ground-level ozone and other harmful substances. Smog is most common in cities with heavy traffic and industrial activity, especially during sunny weather. It can cause breathing difficulties, aggravate asthma, and reduce visibility. Reducing smog requires controlling emissions from vehicles and factories. Let's look at how acid rain forms from air pollution. Acid rain forms when sulfur dioxide and nitrogen oxides in the air react with water vapor to produce sulfuric and nitric acids. These acids fall to the ground as rain, snow, or fog, damaging forests, lakes, and buildings. Acid rain can kill fish, harm trees, and erode stone structures. Efforts to reduce acid rain focus on cutting emissions from power plants and vehicles. Next, we'll explore how pollution affects water and soil. Water pollution occurs when harmful substances enter rivers, lakes, or oceans. Common pollutants include industrial chemicals, agricultural runoff, sewage, and plastics. These contaminants can poison aquatic life, disrupt food chains, and make water unsafe for drinking or recreation. Water pollution is a global problem, but solutions like wastewater treatment and reducing chemical use can help. Soil pollution is another concern, often linked to the same sources. Soil pollution happens when chemicals, heavy metals, or waste products accumulate in the ground. Pesticides, fertilizers, and industrial spills are common sources. Contaminated soil can harm plants, reduce crop yields, and enter the food chain, affecting animals and humans. Cleaning up polluted soil is challenging, but methods like phytoremediation using plants to absorb toxins offer hope. Next, let's see how environmental chemistry helps us monitor and address pollution. Environmental chemists use a variety of tools to monitor pollution. They collect air, water, and soil samples to measure the concentration of pollutants. Advanced instruments can detect even tiny amounts of harmful chemicals. This data helps scientists track pollution sources, assess risks, and develop strategies for cleanup. Monitoring is essential for enforcing environmental laws and protecting public health. Next, we'll discuss how chemistry contributes to pollution control. Chemistry plays a key role in developing technologies to control pollution. For example, catalytic converters in cars reduce harmful emissions by converting pollutants into less toxic substances. Water treatment plants use chemical processes to remove contaminants from wastewater. Air filters and scrubbers capture particles and gases before they reach the atmosphere. These innovations help reduce the impact of pollution on the environment and our health. Let's look at how individuals can make a difference. Everyone can help reduce pollution and protect the environment. Simple actions like recycling, conserving energy, using public transport, and choosing eco-friendly products make a difference. Supporting policies that promote clean energy and sustainable practices also helps. By understanding environmental chemistry, we become more aware of our impact and can make informed choices. Next, we'll explore how governments and organizations address environmental challenges. Governments around the world have introduced policies to reduce pollution and protect the environment. Examples include emission limits for factories, bans on harmful chemicals, and incentives for renewable energy. International agreements like the Paris Agreement and the Montreal Protocol aim to address global issues such as climate change and ozone depletion. These policies rely on scientific research and public support to succeed. Let's see how education and awareness play a role. Education is vital for building awareness about environmental issues. Schools, media, and community programs teach people about pollution, climate change, and the importance of protecting natural resources. Informed citizens are more likely to support environmental policies and adopt sustainable habits. By spreading knowledge, we empower everyone to contribute to a healthier planet. Next, let's look at some success stories in environmental protection. There have been many successes in environmental protection, thanks to chemistry and collective action. The phase-out of CFCs under the Montreal Protocol has led to a slow recovery of the ozone layer. Cleaner fuels and emission controls have improved air quality in many cities. Conservation efforts have restored polluted rivers and protected endangered species. These examples show that positive change is possible when science, policy, and public action work together. Let's discuss ongoing challenges. Despite progress, many environmental challenges remain. Climate change continues to accelerate, and pollution still threatens air, water, and soil in many regions. Emerging contaminants such as microplastics and pharmaceuticals pose new risks. Addressing these issues requires ongoing research, innovation, and cooperation at all levels. Environmental chemistry will continue to play a crucial role in finding solutions. Next, we'll look at future directions in this field. The future of environmental chemistry is full of promise. Scientists are developing new materials and technologies to clean up pollution, capture greenhouse gases, and create sustainable products. Advances in monitoring and data analysis help us better understand environmental changes. Collaboration between chemists, engineers, policymakers, and the public is key to building a sustainable future. let's see how you can get involved in environmental science. If you're interested in making a difference, a career in environmental chemistry might be for you. Environmental chemists work in research, industry, government, and education, tackling challenges like pollution control, resource management, and environmental policy. They use their knowledge to develop safer chemicals, monitor pollution, and advise on regulations. With growing concern for the environment, demand for skilled chemists is rising. Next, let's summarize what we've learned today. Today, we explored the basics of environmental chemistry, including pollution, greenhouse gases, and the ozone layer. We learned how chemical reactions in the environment affect air, water, and soil quality, and how human activities can disrupt natural balances. Understanding these concepts helps us appreciate the importance of science in solving environmental problems. Let's finish by looking at some practical tips for living sustainably. Living sustainably means making choices that reduce your environmental impact. This includes using less energy, reducing waste, choosing renewable resources, and supporting eco-friendly businesses. Small changes like turning off lights, recycling, and using public transport add up over time. By adopting sustainable habits, we can all contribute to a healthier planet. Next, let's explore how technology is helping us protect the environment. Modern technology offers powerful tools for environmental protection. Renewable energy sources like solar and wind reduce greenhouse gas emissions. Smart sensors and data analytics help monitor pollution and track environmental changes in real time. Advances in materials science are leading to biodegradable plastics and cleaner manufacturing processes. Technology, when used wisely, can help us solve some of our biggest environmental challenges. Let's look at the role of community action. Communities play a vital role in environmental protection. Local groups organize cleanups, plant trees, and educate neighbors about sustainability. Community action can influence policy and inspire others to get involved. Working together, people can make a big difference in reducing pollution and protecting natural resources. Next, let's discuss the importance of global cooperation. Environmental issues cross borders, so global cooperation is essential. International organizations and treaties help countries work together to reduce pollution, protect biodiversity, and address climate change. Sharing knowledge and resources makes it easier to tackle complex problems. By working together, nations can achieve more than they could alone. Next, let's look at the role of innovation in environmental chemistry. Innovation drives progress in environmental chemistry. Scientists are developing green chemistry techniques that minimize waste and use safer materials. New catalysts, biodegradable products, and energy-efficient processes are transforming industries. These advances help reduce pollution and conserve resources. Supporting innovation is key to building a sustainable future. Next, we'll explore the importance of biodiversity. Biodiversity refers to the variety of life on Earth, from tiny microbes to large animals and plants. Environmental chemistry helps us understand how pollutants affect different species and ecosystems. Protecting biodiversity is crucial for ecosystem stability, food security, and human well-being. Pollution, climate change, and habitat loss are major threats. By studying these impacts, chemists contribute to conservation efforts. Let's look at the link between health and the environment. Environmental chemistry directly affects human health. Exposure to pollutants can cause respiratory diseases, cancers, and developmental problems. Clean air, water, and soil are essential for healthy communities. Chemists work to identify and reduce health risks by studying how chemicals move through the environment and interact with living things. Public health and environmental protection go hand in hand. Next, let's discuss the importance of sustainable development. Sustainable development means meeting our needs without compromising the ability of future generations to meet theirs. Environmental chemistry supports this goal by promoting cleaner production, resource efficiency, and pollution prevention. Sustainable practices benefit the economy, society, and the planet. By integrating sustainability into all aspects of life, we can ensure a better future for everyone. Let's look at the role of renewable energy. Renewable energy sources, such as solar, wind, and hydroelectric power, are essential for reducing greenhouse gas emissions. Environmental chemistry helps improve the efficiency and sustainability of these technologies. For example, better solar cells and battery materials are being developed through chemical research. Transitioning to renewables is a key step in fighting climate change and protecting the environment. Next, we'll discuss the importance of recycling. Recycling reduces the amount of waste sent to landfills and conserves natural resources. Environmental chemistry is involved in developing better recycling processes and materials. For example, chemists work on ways to recycle plastics and recover valuable metals from electronic waste. Proper waste management also prevents pollution and protects ecosystems. Everyone can help by sorting waste and supporting recycling programs. Next, let's explore the concept of a circular economy. Circular economy aims to keep resources in use for as long as possible, minimizing waste and pollution. Products are designed to be reused, repaired, or recycled, creating a closed-loop system. Environmental chemistry supports this by developing materials that are easier to recycle and less harmful to the environment. Moving towards a circular economy can reduce our reliance on raw materials and lower our environmental footprint. Let's look at the importance of innovation in this area. Green chemistry focuses on designing products and processes that minimize environmental impact. Its principles include using safer chemicals, reducing waste, and increasing energy efficiency. By applying green chemistry, industries can create products that are both effective and environmentally friendly. This approach is essential for sustainable development and pollution prevention. Next, let's discuss the role of environmental regulation. Environmental regulations set limits on pollution and require industries to follow best practices for protecting the environment. These laws are based on scientific research and help ensure clean air, water, and soil. Compliance with regulations drives innovation and encourages companies to adopt greener technologies. Effective enforcement is key to achieving environmental goals. Next, we'll look at the importance of public participation. Public participation is crucial for successful environmental protection. People can get involved by joining local groups, attending public meetings, and supporting environmental initiatives. Citizen science projects allow individuals to collect data and contribute to research. When communities are engaged, environmental policies are more effective and widely supported. Let's wrap up with a final message on the importance of environmental chemistry. Environmental chemistry gives us the tools to understand, monitor, and solve environmental problems. By studying the chemical processes that shape our world, we can develop solutions to pollution, climate change, and resource depletion. Everyone has a role to play, from scientists and policymakers to individuals making everyday choices. Together, we can build a cleaner, healthier, and more sustainable future for all. Thank you for joining us on this exploration of environmental chemistry. We've seen how pollution, greenhouse gases, and ozone layer reactions are all connected through chemical processes. By understanding these links, we can make informed decisions and take meaningful action to protect our planet. Stay curious, keep learning, and remember that every positive step counts in the fight for a healthier environment.